I can't even trust you or Claire or anyone in that group that you guys sit with. That's how it should be. I trust you to yeah. That's all right. I'm going to text him to you can send pictures. Oh, I guess you can.
Okay, so we're going to learn a little bit about sequences today and different ways to use functions to generate sequences. So an example of a sequence would be, let's say we start with the number 3, and then the next number is 7, and the next number is 11, and the next number is 15. So that's just a list of numbers. Sometimes sequences have a pattern that you can recognize, and sometimes they don't. In this case, does anyone recognize the pattern that we could use to generate that sequence of numbers? Natasha?
It's number plus 4.
Okay, good. So if you take any term in the sequence, you can add 4 to get the next term in the sequence. Okay? And so we're going to use some algebraic notation to describe these. So if this is the first term, the algebraic symbol that we'll use for this is f of 1. So the 1 means first term. So then this is the second term. And so we would call that f of 2. So the 2 tells us the term number. Okay? This is the third term. So what would we call it? F of 3, and so on. So then this would be the fourth term. And we would algebraically write it as f of 4. And this series could go on forever. And so if I wanted to know the 10th term, that would be f of 10, and so on and so on. Okay? So sometimes we have formulas that we can use to generate these kinds of sequences. And there are two different types of formulas that we're going to work with. One is called a recursive formula. And the other is called an explicit formula. Okay, in a recursive formula, finding out a certain term in the sequence requires us to know the terms that came before it. Okay, so for example, one way to write this sequence that I have up at the top, 3, 7, 11, 15, one way to write that recursively would be to say f of n is equal to f of n minus 1 plus 4. Now that might look kind of confusing, but if we think of it with numbers, let's say, for example, I wanted to know f of 2. I already know the first term. Remember, we know the first term is 3, so let's say the first term is 3. Okay? So if we know the first term is 3, what this formula is saying is that if I plug in 2 for this n, then I need to plug in 2 for that n as well. So this is going to be f of 2 minus 1, which is, plus 4. So f of 2 minus 1 plus 4. And so 2 minus 1 is 1. Okay? F of 1 plus 4. And what is that? Do we know what f of 1 is? F of 1 is 3, so in place of f of 1, I can write what its value is, which is 3 plus 4 is 7. So that looks like a lot of work, a lot of steps that we had to go through. But what we really want to recognize, I'm going to write this series again. Actually, let's do one more. Let's do one more so you can kind of recognize this with numbers. So now if I wanted f of 3, what's going to be in parentheses here? According to this formula up at the top, I put 3 in place. Since I put 3 in place of the first n, I have to put 3 in place of all the n's. So this is going to be 3 minus 1 plus 4. And that is f of 2, because 3 minus 1 is 2. And do we know f of 2? Does anyone know what f of 2 is?
7.
How did you know it was 7? You're right. How did you know it was 7?
Because it was the one, because you plugged in 2.
Because that's what we just got on the previous problem, right? Remember what we did right here? We just calculated f of 2 and we found out that it's 7. So f of 2 we know is 7. And so when we add 4, now we get 11. Okay? So that pattern is going to continue on and on and on. But what I want you to recognize is that when we wanted to know f of 2, which value did we need to know? F of 1, which is the one that comes right before it, right? And when we wanted to know f of 3, we had to know f of 2, which is the term that comes right before it. So all this is doing right here, the f of n minus 1, all that's doing is it's referencing the term that comes right before it. So I'm going to rewrite this formula. This is f of n equals f of n minus 1 plus 4. When we subtract 1 from the term number, all that's doing is giving us the previous term. So if I want to call this the current term or the next term or something like that, so current term is equal to this. What would be a word to describe this? If f of n is the current term, what is f of n minus 1? What did we do up here in the problem? When we wanted f of 2, we needed f of 1, which is the one that comes right before it. So this would be the previous term. So if I want to find out what the current term is, I just take the previous term and add 4. Okay? So to get any term, all I have to do is find out what the previous term was and add 4. So far we found out that the first term is 3, the second term is 7, the third term we calculated as 11. All we're doing is taking the previous term and adding 4. That's what this formula is telling us to do. So if we think of it in words instead of algebraically, okay, this algebraic, all these symbols in this box, that looks kind of confusing. But if we recognize that the n minus 1, that's just going to back us up by 1. That's always going to be the previous term. So to get this sequence, if we can write these things in words, then and recognize that it's just the current term is always equal to the previous term plus 4, then I can generate this series really easily just by taking the term and adding 4. So if I want to know the fourth term, I take the third term and add 4, and it's 15. Allison?
Why not for like the n minus 1? Why not do like n minus 2?
Then we would be backing up 2 terms. So that if you did n minus 2, then if I wanted the fourth term, you would need the second term. So that's, if I subtract 2, I'm not sure why you're saying we would subtract 2. Let me show you. Let me pause this. Okay, so whenever you see the n minus 1, that means it's going to be the term that comes right before it. Okay, so the next term then, if I want the fifth term, because remember we said this is f of 1, this is f of 2, this is f of 3, this is f of 4. So if I want the fifth term, which we name f of 5, all I have to do is take the previous term, add 4 to it, and I get 19. Add 4 to that, and I get 23, and so on and so on and so on. So this is called a recursive formula, because to get any term in the sequence, I need to know the term that came before it. Okay, so that is something that is true of all recursive formulas, is that we can't just, if I wanted the 20th term, I wouldn't be able to get the 20th term without knowing the 19th term. And I wouldn't be able to get the 19th term without knowing the 18th term. And I wouldn't be able to get the 18th term without knowing the 17th term, and so on and so on and so on. So you have to start, you have to have a starting point. So that's why we had to know, you had to be given this as a starting point, and then we just kept adding 4, adding 4, adding 4, because remember when we wrote this in words, it said the current term is the previous term plus 4. Okay? So I can't get to the 20th term without finding all the terms that come before it. So that is one disadvantage of a recursive formula. Even though they're pretty easy to use, just add 4, add 4, add 4, I can't really jump ahead using a recursive formula. Okay? That's where the explicit formula comes in. An explicit formula allows us to generate a sequence explicitly. That means we don't have to build it from the beginning. We can jump to any term. So for example, the explicit formula for this function would be f of n is equal to 4n minus 1. Now you don't need to know where that came from. We will explore that in another chapter. But for now, if f of n equals 4n minus 1, I can generate the series just by plugging in numbers. So if I want to know the first term, I plug in 1 for n. So if I put 1 in place of that n, I have to put 1 in place of that n and subtract 1. So my answer is 3. If I plug in, if I want to know f of 2, that's the second term. That is 4 times 2 minus 1, which is 7. Zolfi, what would f of 3 be? $11. So we would do 4 times 3 minus 1. That's 12 minus 1 is 11. And Corbin, what would f of 4 be?
It would be 15.
15 is right. So we have 4 times 4 minus 1. See, all I'm doing is using this formula. When I plug in 4, I get 16 minus 1, and that is 15. So 15 is correct. Now the nice thing about an explicit formula is that I can, if I wanted to know the 20th term, that would be named f of 20. If I wanted to know the 20th term, I can do that with an explicit formula without having to know the 19th term and the 18th term and the 17th term and so on, just by simply plugging into the formula. So that's going to be 4 times 20 minus 1. That would be 80 minus 1 is 79. So I can get the 20th term using an explicit formula without having to get all the terms that come before it. Okay? So an advantage of a recursive formula is they're easy to use and easy to write. An explicit formula is going to be sometimes harder to create the explicit formula, but once you have it, it's very powerful because I can jump to any term number that I want without having to find all the ones that come before it. Okay? So you're going to do some problems in this section using both explicit and recursive formulas. Okay? So let's look at the problem that you did in last night's assignment, number 3. So if you want to open up your book to page 161, you can follow along with this one. Some of you may have gotten it already, and some of you maybe got stuck, so let's work it out together. So we have, for problem number 3, we have f of 1 equals 65,536. And they give you a formula that says f of n equals the square root of f of n minus 1. Okay. Would you say that that is an explicit or a recursive formula? Does anyone know? Huh? Okay, well, it is recursive. How do you know it's recursive? It has, what part of the formula tells you it's recursive? Can anyone answer that?
Because it gives you the previous number.
You're right. Where do you see that? Where's the previous number?
On the left side.
What part?
Or
What part of this references the previous number?
the function here, 1. Or equals 65. 556.
This is just telling us the first term.
Ah.
Okay, so that is actually a clue. They're giving us the first term, and we only really need to be given a term if it's recursive. So I think maybe that's what you're saying is, since they're giving us the first term, it's probably recursive because we're going to build upon that. But I'm looking more in the formula side. What do you see, Jassim?
The parentheses.
What part of the, I see parentheses here and over here.
I meant
On the right side or the left side?
the right.
Yes, on the right side, see the f of n minus 1? What did we say in the previous problem? When we see f of n minus 1, what do we say? What are the words that describe f of n minus 1? Look in your notes, we just did it. When we converted it into words, if you took good notes, or if you're looking at the screen right now, Cece?
Previous term?
Yes, when you see f of n minus 1, that always means the term that comes right before f of n. So that always means previous term. So if you have a formula that is referencing the previous term, then it has to be recursive. Okay? That's the only kind of formula that references a previous term, and so this is a recursive formula. Okay? So I know this is new. We're going to get lots of practice with it today. So this is a recursive formula. Another hint is that in a recursive formula, there's an f on both sides because you have f of n references the current term, and f of n minus 1 references the previous term. So if there's an f on both sides, it's probably recursive. Look at the previous example that we did. On the explicit formula here, there's only an f on one side. Only on the left. On the right side, it was just 4n minus 1. There was no f there because we weren't referencing another term. Okay? So explicit formulas only have an f on the left side, whereas a recursive formula is going to have an f on both sides because we're building one term from another term. Okay? So if I wanted to state, I'm just going to rewrite this. If I wanted to state this recursive formula in words, it'll make this problem a lot easier. So this might be the hardest part of what we're doing today, but it's also the most important, and it'll make things so much easier if we can learn to write this in words. Okay? Does somebody want to try it? How could I write this equation in words? We almost have it already. Okay, Rachel?
The square root of f times 2 minus 1.
No. Okay, Andre?
The current term equals square root of the current term minus 1?
What are we calling this? We didn't call it. This is current term.
The previous term.
Okay, so state that again. I think you have it.
So the current term equals square root of the previous term?
Perfect. So this is what we want to say when we see this. The current term is f of n, that's the term we're trying to find, is equal to the square root of the previous term. That, as soon as we write that, now it's really easy because all we have to do is look at the previous number and take its square root. Okay? So we know that f of 1 is 65,536. If I want the next term in the sequence, according to what Andrea just said, all we have to do, if I want the second term, all I have to do is take the square root of the first term. Okay? And that is the square root of 65536. You might need a calculator to get that. What's the square root of 65536? 256. And then to get the third term, so this was the second term, to get the third term, that's called f of 3, we're going to take the square root of what, Brandon?
Of 65,536.
No, we did that here. To get the second term, we took the square root of the first term. So to get the third term, we're going to take the square root of the what is previous to 3? 2. So we're going to take the square root of the second term. Which was 256, so that is 16. Okay? So to get the fourth term, f of 4, what am I going to take the square root of? Kaylee?
16.
Take the square root of the previous term, which is 16, and that is 4. Okay? So by writing it in words, I don't have a lot of calculations to do. I just follow the pattern. It says to get a new term, I take the square root of the term that came before it. So if we're given that the first term is 65,536, then the second term is going to be the square root of that, which is 256. The third term is going to be the square root of that, which is 16. And the fourth term is going to be the square root of that, which is 4. Okay? So it follows that pattern. That's why once you learn how to say these kinds of formulas in words, they suddenly become a lot easier. It's kind of confusing when you look at this formula, but if you understand that the f of n minus 1 always means the term that came right before the one we're looking at, or the one we're trying to find, then all we're doing is we're taking the square root of that. Okay? So now let's take a look at problem 4 from yesterday's assignment. That is f of n is equal to n cubed minus 1. Have a 20-second discussion at your table to decide if that is recursive or explicit and why.
Because it's like a minus 1.
And there's only f on one side of the equation. So do we have to write an explicit on it? All right.
Okay, Yukai, what'd you guys decide? Explicit or recursive?
Explicit.
Okay, it is explicit, you're right. And why? How do you know?
Well, there's F1 F, and there's no F on that.
Okay, there's only an f on one side, and so that means the right side isn't referencing a different term. We can think of explicit as meaning direct. We can calculate any term directly. If I wanted to know the 7th term, I could calculate the 7th term directly or explicitly without having to rely on the terms that come before it. Okay, so you're right. And so now go ahead and calculate. Well, let's do f of 1 together, and then I'll have you calculate the other ones that come after it. Okay, so f of 1, if I put 1 in place of that n, then I have to put 1 in place of that n, so that is 1 cubed minus 1. What is that? 0. So the first term is 0. Go ahead and calculate f of 2 and f of 3 and f of 4 using that same explicit formula. Okay, Anisha, what'd you get for f of 2? 7 is right, and what did you write to get that? If I was going to plug directly into the formula.
2.
Good, 2 cubed minus 1. So I replace that n with a 2, and that gives me 7. Okay? Then f of 3, Nico?
For f of 3, I got 26.
And what'd you do to get that?
I get 3 cubed minus 1, and 3 cubed is 27. So subtract 27 by 1, you get 26.
Good, thank you. And let's see. Jackson, what'd you get for f of 4?
So I got, can't really tell what I wrote down.
Okay, can we do it together right now? Our formula is f of n is equal to n cubed minus 1. So what should we write down?
So 4 to the power of 3. 4 cubed minus 1.
And 4 cubed is 4 times 4 times 4?
Yeah.
What's that?
So 4 times 4 is 16 times 4. I can do this.
That one, you may not know that one, you might not have that one memorized. 4 times 16, who knows it? Okay. 64. And then we subtract 1, so this is 64 minus 1, and so we end up with 63. Okay? All right. Thanks for your help on that, Alex. Okay, so what do you think is easier, explicit or recursive? Okay, for this one, explicit looked easier. So remember we said explicit is really, it's definitely more powerful because if I wanted to know any term, if I wanted to know the 100th term, I could find it easily. If I wanted to know the 30th term, I could find it just by plugging in 30. Okay, so we could do that. We could say f of 30, that's the 30th term, would be 30 squared minus 1, or sorry, 30 cubed minus 1. That would be a pretty big number, but I could calculate that. So what's 30 squared? 900, and then times another 30 would be 27,000 minus 1.
26,999.
Okay, good. Okay, let's see. Look at number 5 in your book. Now, at this point, you can make the decision whether you want to do everything else in your book, or since there's not very much space, in my opinion, they didn't leave you enough space to do all of the work that's required to do problem 5. If you want to keep doing these on your note page, that's fine. So it's up to you, but I would like you to try number 5. So first, take a look at what they give you and decide if it is recursive or explicit. And discuss that in your groups quickly, please.
Oh, you're number 5. Okay, that's recursive.
Okay, so even if you're not done, I think you'll benefit by just watching and listening for a moment. So put your pencils down. I will give you time to write. Okay? So you just need to try to focus and listen for a minute. This can be difficult if you're not really paying attention to what we're doing, but I think you'll once you get good at these, you'll find these recursive formulas are can be pretty easy. Okay? So what we did in the previous problems is we said that whenever we see f of n minus 1, like we see here, that references the term that comes right before the one that we're trying to find. Okay? So we call that the previous term. Now what I want to do first is show you what this looks like if we don't try to translate this into words. Okay? Because we can do it without translating it into words, but it's a lot of math, a lot of arithmetic, stuff like that. So here's how it would look. If I wanted to know f of 2, for example, so this is kind of the long way to do it. If I wanted to know f of 2, guys, I want everyone to just watch up here. Don't do anything else with your calculator, your pencil. Just watch up here, please. So negative 2, or f of negative 2, that means second term, right? If I want to know the second term, and I just follow the formula directly, right here, I put 2 in place of that n, so I have to put 2 in place of this n also. So it would read negative 4 times f of 2 minus 1, because I just took this n and I replaced it with a 2, and then we add 15. Okay? So then we have to go through this in several steps. Negative 4 times, well, I know that 2 minus 1 is just 1, so that's really f of 1. And do I know f of 1? it was given right here, is 7 plus 15, and that is negative 28 plus 15, which is negative 13. Okay? And then to get the third term, still don't write yet, just keep watching. Okay? So the third term, doing it the long way again, would be negative 4 times, back up here at the formula, it says, if I put, here, let me actually write it. So the third term would be f of 3. If I'm putting 3 in place of n, it would be negative 4 f of 3 minus 1. Nico, do you need to step outside?
No.
Okay. Then control yourself and just focus right here. So negative 4 times f of 3 minus 1 plus 15. 3 minus 1 is 2. And do we know f of 2? We found it right here, is negative 13. So now I can put negative 13 in place of f of 2. And when I multiply this out, I get positive 52 plus 15 is equal to 67. Okay? So this is kind of the long way to do it. What I really want you to get to is doing, so this is the long method. Okay? It works, but it's a lot of work. Okay? Let's do the smart method, the efficient method. Okay? The smart method would be to take this and just write it in words. All this is saying is that to get my new term, I do negative 4 times, we said whenever we see f of n minus 1, that means previous term, plus 15. So every time I want a new term, all I have to do is take the previous answer I got, multiply by negative 4, and add 15. So watch how much easier this is. F of 1 is 7. So f of 2, according to our sentence that we wrote up here, is to get this current answer, or my next answer, I do negative 4 times my previous answer plus 15. And that is negative 13. And then to get f of 3, I just do negative 4 times my previous answer plus 15, and that is 67. Okay, so this is a lot easier if we say it in words. Then we realize all we're doing is taking our previous answer, multiplying by negative 4, and adding 15. We can do that over and over and over again. So now go ahead and catch up on writing and calculate f of 4. You make the choice of calculating f of 4 the long way or the smart, efficient way. Okay, take your pick. Go ahead and work that out and catch up on the writing. Okay, so if we use the smart, efficient method and we realize that all we have to do to get the fourth term is do negative 4 times the third term, which is 67, and add 15, and that gives us, is it 253? Negative 253, thank you. Negative 253. Okay, good. So now I'm gonna skip 6 for the, well, no, let's do 6. 6 is explicit. We have f of n equals 2n squared plus 4. So this should be pretty fast, because the explicit ones, you just plug in the number in and going. Okay? Go ahead and calculate those. Use your calculator if you need it, but I think you'll be able to do all, maybe all but the last one by hand or in your head. Maya, what'd you get for f of 1?
6.
Good. And so what expression should we write to get 6?
2 times 1 squared plus 4.
Perfect. And so that is 6, you're right. And Elizabeth, how about f of 2?
12.
And how'd you get that?
2 times 2 squared plus 4.
Okay, very good. And Ashley, how about f of 3?
16.
So 2 times, what are we squaring?
3.
2 times 3 squared plus 4. And so that's 9 times 2 is
So 18.
18 plus 4. 22. Okay, so f of 3 is 22. And Cameron, how about f of 4?
36.
Okay, good. 2 times 4 squared plus 4 is 36. Because it's 2 times 16, which is 32, plus 4 is 36. Okay, so that one is explicit. Okay, let's look at 7. 7, they give us the first term. F of 1 equals 3. It's not time to go yet. F of 1 equals 3. All I want you to do with 7 is talk in your groups for 30 seconds. How would you write number 7, which is f of n equals f of n minus 1 squared? How would you say that in words? That's what I want you to discuss right now.
Do what you're having.
Don't pack up. Do not pack up.
Previous term squared.
We're not done. It's not time to go yet.
Okay.
Okay, Cece, how would you say that in words?
I would say previous term equals, current term equals previous term squared.
Good. Current term equals the previous term squared. So that should be really easy to come up with. If you just take 3, what's the next term going to be? 9, and the next term is going to be? 9 squared is 81, and then the last term is hard. 81 squared, that's a bigger number, so you'll use a calculator for that. Okay? Good job today, guys. Have a good weekend.